Hello, young math padawans, and welcome back. It's Mrs. Angel with lesson number 2 on solving quadratics. We're going to kick off this unit by solving our quadratics first using intercept form. Why? Because it's the easiest one to use, and you've actually already done this math while you were doing graphing. So as opposed to graphing, when we're given an equation, a function, a quadratic function specifically, instead of being set equal to y, as it would be if we were graphing, we're only looking for one particular or two particular solutions, the solutions that provide an output of 0. So in other words, we're looking for the x's that give us 0 for the y. Now that could be two solutions, one solution, or none at all. That's what we're trying to figure out. So how do we solve quadratics in intercept form? We use something called the zero product property. Now the zero product property officially states that if a product of two or more quantities equals 0, at least one of the quantities equals 0. It's a fancy way of saying if you're multiplying two numbers and one of them is 0, 0 times anything is always 0. So grab some notes and let's get started. So what's different about solving versus graphing, again, is that this function we would normally see set equal to y, and then we have to set up a table of values. But instead, we're only looking for the values that produce an output of 0. The zeros of this function. So according to the zero product property, because this is a product of two different groups set equal to 0, when this group equals 0, this will be a true equation. And when this group is set equal to 0, this will also be a true equation. So there's a couple different ways to do this. You could use the process of setting up and solving equations, or as I'll show you after, you could do this mentally. So let's say we were to set up two equations. That would be that both of those products, both of those groups are set equal to 0. From here, we would simply solve both of the equations. That would lead us to n equals -7 and n equals 3. Now, you could have also figured this out mentally just by looking at the products themselves. If I look at that first group, what plus 7 equals 0? That would have to be -7. And what minus 3 equals 0? That would have to be +3. So you can set up and solve equations, or you can use some mental math. Either way, there's some checking that has to come next. And you have to check both solutions in the original function you were given. So let's go ahead and start by checking n equals -7.
-7 plus 7 times -7 minus 3 equals 0, but 0 times -10 equals 0.
And from here, the zero product property states that if you have a product and one of the factors is 0, this is a true equation. 0 equals 0, and -7 is one of our solutions. Now we'll check +3.
3 plus 7 times 3 minus 3 equals 0. That's 10 times 0 equals 0.
Again, according to the zero product property, because one of those factors is 0, this is a true equation, and 3 is also a solution. So what does all of this actually mean? This means that the quadratic here that's written in intercept form has two zeros. And those zeros are -7, 0 and 3, 0. So imagine a parabola, the vertex somewhere in between, it's crossing over here at -7 and also over here at +3. We have now successfully solved this quadratic, no graphing needed. So here we have example 2. It's still in intercept form, even though we have a coefficient out in front. So you're still trying to find the values of n that make this equal to 0 according to the zero product property. You can either do this by solving or you can do it with mental math. Either way, give this one a shot now. Here I have it solved, but you could have also figured out that the only number +6 that makes 0 is -6, and the only number +7 that makes 0 is -7. Of course, we have to check both of these solutions in the original function to make sure that they're true. So let's start with -6.
6 times -6 plus 6 times -6 plus 7 equals 0. 6 times 0 times 1 equals 0.
Here, because of zero product property, I have a product where one of them is 0. 0 times anything is 0, and I know that this is true. Now let's check -7.
6 times -7 plus 6 times -7 plus 7 equals 0. 6 times -1 times 0 equals 0.
Again, by the zero product property, because one of these factors is 0, 0 times anything is 0, and -7 is also a solution. So what does all of this mean? Again, this means that the quadratic we were given has two zeros. They are -6, 0, and -7, 0. So imagine a parabola crossing the x-axis at -6 and -7. The vertex is somewhere in between. And now we have successfully solved example number 2. On to example number 3. This one might be a little tougher to do mentally, but I'm still going to have you try to do it on your own now. So you probably could have used mental math in the second group to figure out that it's -3, but because this first group has a product, you might have wanted to set up and solve. Either way, you end up with 4/5 and -3. Time to check both solutions to see if they're actually true. Starting with n equals 4/5.
5 times 4/5 minus 4 times 4/5 plus 3 equals 0. That's 4 minus 4 times 3 and 4/5 equals 0. 0 times 3 and 4/5
equals 0. Now, because that first quantity has a value of 0, that first factor is 0, by zero product property, this equals 0, and 4/5 is a solution. Now let's check n equals -3.
5 times -3 minus 4 times -3 plus 3 equals 0. -15 minus 4
times 0 equals 0, and I don't even have to keep going. One of these factors is 0. By zero product property, 0 times anything is 0, and this is true. So -3 is also a solution. So we ask ourselves, what does all of this mean? Unsurprisingly, again, this means that this quadratic has 2 zeros. They are 4/5, 0, and -3, 0. This is an example of a parabola that would be very hard to graph and find the zeros because one of our zeros is a fraction. That's why solving exists. Final example. Now, this doesn't look like intercept form, but actually it is. That first part, 8r, could also be its own little group, and you can still figure out the two values of r that make this equal to 0 using the zero product property. So why don't you try this one on your own now? So whether you use mental math or setting up equations and solving, I ended up with 0 and -5. So here, mentally, I know that -5 plus 5 is the only way to get 0. And because this is multiplication, the only way to produce 0 in a product is to plug in 0, hence the zero product property. Either way, it's time to check our work, starting with r equals 0.
8 times 0 times 0 plus 5 equals 0. That's 8 times 0 times 5 equals 0.
Because this is a zero product, by the zero product property, this is true, and 0 is a solution. Now let's check r equals -5.
8 times -5 times -5 plus 5 equals 0. That's 8 times -5 times 0 equals 0.
Because I've got a 0 in the product, by zero product property, I know that -5 is also a solution. Alas, what does this mean? But of course, this means that this quadratic here in intercept form also has 2 zeros, and they are 0, 0, and -5, 0. So in closing, when you're given a quadratic in intercept form, it's a lot faster to use the zero product property than it is to graph and try to find those zeros. That's it for this lesson. I will see you next time.